Saxon Math. We're in lesson 51, and we are going to be looking at a lesson that deals with something called scientific notation, and also dealing with large numbers. Okay, and large numbers are meaning like in the billions, trillions, or even larger. Okay, so here we have a number. Okay, I've listed right here, and in your textbook on page 363, you notice here's the hundreds, here's the thousands, here's the millions, billions, so trillion right here, 9 trillion. How can we write 9 trillion 461 billion in a simpler way? Way simpler. All right, here's what I want you to consider. Okay, I'm going to do this in red. We are going to move the decimal point to right here. Okay, just not arbitrarily, we're just going to do that because we want one digit and then the remaining. How many places did we move it? Okay, well, the decimal place was right there, right? Because it would be 0.0009. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and there's the decimal point. So here's what the number looks like now. We're going to say 9.461 and times 10 because of all these zeros, and we counted 12 places, right? 3, 6, 9, 12 decimal point. So the decimal point was moved 12 places from right to left. Okay, we went this direction, and when we go right to left, that means we add an exponent. In this case, it's a positive 12. If we were to go the opposite way and move it this direction, we would be subtracting, okay, an exponent, and you can have a negative here demonstrating that. We won't get to that quite yet, but just want to give you some basics here, okay? So what I want you to do is I want you to turn the page to 364, and then you're going to see a chart up there, and it's going to give you some kind of ideas, right? So we've got pencil lead, diameter of a quarter, length of a dollar bill, length of an average car, basketball court, and so on, and they're all in millimeters. So we're just using huge numbers of millimeters and condensing them down, okay? Let's go to example 1, because example 1 gives us some of the work that we're going to get in our textbook. So it says this: there are 8.64 times 10 to the 4th seconds in a day. Show this number is written in scientific notation. Okay, so when it says 8 point, that is 8 decimal point 64, okay? And then it says times 10, here's our times 10, to the 4th seconds. Well, what's to the 4th? Well, 4th is this exponent. That's the power that they're asking for, okay? So this is called scientific notation. I'll abbreviate for SN, okay? Scientific notation. And I want you to notice scientific notation is specific to having only one digit on the side of the decimal, and there can be all kinds of digits on this side, okay? It doesn't matter. It just matters that it's one. In other words, you can't have it like this. It can't be 86.4 times 10 to the 3rd power. We have to move this here, which is 8.64 times 10 to the 4th power. This is kind of correct, but it's not proper scientific digit or scientific notation, okay? All right, what if we have a scientific digit number? How do we put that back into standard form? Standard form just means its original number with all the zeros in it, okay? So in example 2, they give 2.46 times 10 to the 8th power. So let's write this without the times 10 to the 8th, 2.46. So here's what that means. That means we moved the decimal point to the left 8 digits. That means to get this to 0 or standard form, we're going to have to move it to the right 8 times. So here's 1, 2, 3, 4, 5, 6, 7, 8. There's the decimal. In all these little troughs, we put zeros. Why? Because we multiplied it by 10 times 10 to the 8th power. So really, our number is going to be 200. I mean, if we put commas in here, it's 246 million. See, scientific notation isn't really that difficult. It's just about making large numbers manageable. Okay, we can write it in a short amount of time. This is half the distance, right, of writing this whole number out. So this does save time, save space, save energy. All right, let's look at example 3. You've got a number here of 40,720,000. Okay, write in scientific notation. How do we do this? Well, remember, we only want one number here and then a decimal. So how many times does it go over? 1, 2, 3, 4, 5, 6, 7. So we know that it's times 10 to the 7th, right? What do we put here? Well, 0.072. We only put this number in here because after it comes to zeros, that's where the times 10 comes in. We don't have to worry about that anymore. We know those are automatically zeros, okay? So the answer is 4.072 times 10 to the 7th power, because if we moved it 7 times, we would get 1, 2, 3, 4 zeros, right? 4 zeros plus 3 other digits, 1, 2, 3, equals 7. Okay, that's how we come up with our power. All right, so there's example 4 is just a comparison, which is larger, which is smaller, and you can see how that works, and I think you understand that this is greater than, this is less than, this is equal to, and again, we're looking to come up with those answers in a comparison of scientific notation. So you're going to write out the scientific notation and put those in as you would normally. Okay, that's your lesson for today, lesson 51. Hopefully you do great, and if you have any questions, I'll be more than happy to answer.